Okay, so hello, good morning, good evening, good afternoon, everyone, depending on where you are. Today is a pleasure to host Michela Johnson from the Natural History Museum of Stuttgart, and she's going to be talking about Jurassic giants, exploring the ecology and evolution of Teleosauroids. So before we proceed to the actual talk, if you're familiar with PALAEOHISTOLOGY seminars formats, we usually start with these short welcome and announcements. Afterwards, we have the talk itself, which is followed by a moderated Q&A for about 10 minutes. And after that, we have a tea time session, which is a great opportunity for everyone to chat a little bit more about the talk, talk about Michela's research and other stuff. And this is the first reminder that if you have any questions for Michela about the talk and you want them to be read by me, please send them via chat to the questions host that today is going to be Chrissy, if I'm not wrong. So before we start the talk, before I introduce Michela, actually, we have some housekeeping messages. First is that here at PALAEOHISTOLOGY, we value the participation of everyone interested in the paleosciences. And we have a code of conduct that we ask everyone to abide by. If you're joining this seminar without doing this, please go to our website and do this. Please remember to stay muted during the talk. If you are able to unmute yourself, please don't do this. You shouldn't be able right now, but if you can, please don't unmute yourself. Another reminder that you can send your questions to the PALAEOHISTOLOGY questions host. And if you want to press the button raise hand during the moderated Q&A session, you can do so, and I can allow you to unmute yourself and you can ask the question yourself. We have captions, built-in captions from Zoom. You can allow them to show if you press the little CC button, and you can hide them as well. Remember to, if you know an outstanding early career researcher, please remember to nominate them via our form for this. We're going to see a link for this in the chat in a few seconds. There we go. And also we have a demographic information feedback that we ask everyone to fill out this information. It's anonymous, it's optional, but it's very much encouraged because it's important for us. So finally, introducing Michela's, she has done a bachelor's at the University of Alberta in Canada, followed by a master's at the University of Southampton in the UK, and a PhD at the University of Edinburgh, also in the UK. And she's now a postdoc at the Natural History Museum. I can't speak this in German, sorry, at Stuttgart, in Germany. So please, Michela, you can take the screen share and start the talk.
Alrighty. Well, thank you very much for the introduction, Pedro, and I hope you guys enjoy the talk. We'll see.
Thank you. Have a good talk.
Screen's okay?
Yeah, it looks
okay.
Good.
All right, yeah. Brilliant. Okay, well, thank you all for being here. I really appreciate it. Listening to me chat a little bit about my favorite crocodiles and what I'm currently working on at the Staatliches Museum für Naturkunde in Stuttgart, which is also hard for me to say in German. And if you're interested in chatting with me about crocs later on or whatnot, then feel free to send me a Twitter message or an email. I'm always on email and I always love to talk about crocodiles. So I'll first give you just a very brief introduction of Crocodylomorpha in general, which I'm sure a lot of you do know, so I'll try and make that quick. Then I'll focus a little bit on what I did during my PhD in Edinburgh on the Teleosauroids, the Jurassic crocodiles that I specialize in. And then finally, a little bit about what I'm doing now, a little bit of leftover work from Edinburgh, and also what I'm doing in a postdoc in Stuttgart. So before I forget, I want to thank everybody, eoPERCS for having me, of course, you guys for listening. Stuttgart Museum, the paleo group there has been fantastic, only 3 months in so far. University of Edinburgh, colleagues, museums, curators, funders, everybody that's helped me get to where I am today. Thank you very much. So everybody knows what a modern crocodile or an alligator or a gharial looks like. Reptiles, cold-blooded, sprawling limbs, large mouths, long skinny mouths in the gharial. And generally, the public assumes that this is what all crocodylomorphs look like. Where in fact, we do know that in the fossil record, there's an amazing amount of diversity. There's ones that superficially look like whales. There's some that ran somewhat like horses, some that ate plants, some that had cat-like teeth, some that may have been facultative bipeds. Also, of course, really large ones like the Teleosauroids from Brazil and Sarcosuchus from Africa. So what we're going to focus on today is objectively the coolest fossil crocodylomorphs, which are their Thalattosuchians. And they're into two main groups. So the Metriorhynchoids, which most people are familiar with, the more whale-like, quote unquote, crocodiles, and the Teleosauroids, which are considered the more gavial-like Thalattosuchians. So they're both interesting, obviously, in their own right. They both have very sophisticated body plans, very unique body plans during the Jurassic, and they were the top predators within their ecosystems. However, today we're going to focus on the Teleosauroids. Before we go into that, why are Thalattosuchians important? Well, they were the first group of crocodiles to actually go from land back into the water, which is a major evolutionary transition and one that is quite astounding when you think about it. So they're important, they're really important for understanding how adaptations have changed from moving from a land-based environment back into an aquatic-based environment. So things like limb development, their sensory organs, their brains, their ears, etc. So straight to the Teleosauroids, which I would argue, in my very biased opinion, are they're more interesting, I think, than the Metriorhynchoids, just because in a diverse body plan sense, they have a lot more diversity going on. So generally, they're thought of as long-snouted, multi-toothed crocodylomorphs. They were dominant, abundant, and near globally widespread within the early Jurassic to the early Cretaceous. And part of my PhD work was to figure out how diverse these things actually are. What are the evolutionary relationships between taxa within this group? And they also have some pretty crazy historical artwork, which is just, I think it's amazing. It's an absolute trip. Like the ones on the far left right here, eating platypus. This one at the bottom right, I have no idea what it's doing in the water. It looks like it's had one too many pints at the pub. In short, there was a lot of work actually done on Teleosauroids from the early 1700s up until kind of the mid 1900s. And there was a lot of naming new species, a lot of naming new taxa, and then it kind of died down. The Teleosaurid fate died down a little bit until the early 2000s, when there was really a resurgence in work on this group of crocodiles. And Mark Young from the University of Edinburgh, one of my co-authors and a good colleague of mine, he really spearheaded a lot of the Teleosaurid work. So I worked a lot with Mark on taxonomic related issues and evolutionary phylogenetic related issues as well. So historically, they were thought to be very conservative. So they were all thought to look the same except for the skull. This is not the case. If there's one thing you can take away from this talk, it's that they're not conservative. They are actually really quite diverse, not only in terms of skull and mandibular anatomy, but also in their forelimbs and their osteoderms as well. So what I did for my PhD is I looked at roughly 550 specimens from museums around the world. You can see in this photo of the world, the black arrows are where I visited, countries I visited, and the red ones are all other countries, institutions that I contacted either for additional help or discussion or more photos or anything, specimen information, things like that. So I wanted to have a really quite big data set of Teleosauroids because there wasn't really one out there yet to do my phylogenetic analysis. And so what I found was that there is quite a lot of diversity within this group. We've got intermediate forms like B. herberti right up here in the left corner. We've got things with lateral eye sockets like Plagiophthalmosuchus right here in the right, top right. Taxa with these big kind of interlocking osteoderms, almost like a mini shield, if you will. Platysuchus right here at the museum in Stuttgart. We've got Machimosaurini. So everybody knows Machimosaurus with the turtle crushing teeth, or Lemisuchus as well, right here in the middle left. Then we've got freshwater taxa, which are primarily from East Asia, which is really quite interesting, as this Thai specimen down here on the bottom left. And then we also have forms that are slightly more benthic than other teleosauroids, as evidenced by telescopic orbits, very small forelimbs, and reduced osteoderms like Eolodon right here on the bottom right. So in terms of diversity, in terms of habitat, there's a lot to understand what's going on with these guys. So part of my PhD, the main part of my PhD, I should say, was putting together this big phylogeny of teleosauroids. So we had a total of 153 crocodylomorph taxa, 27 were teleosauroids, with over 500 characters. I can't remember the exact number, 505 or something like that. But we put it all together and we found, okay, here's this really, really nice distinction of these two groups, which we're going to call family T. So teleosaurids, which include the phenotypically plastic or kind of bizarre looking teleosauroids, the things with the telescopic orbits, all the East Asian taxa that are freshwater, these benthic forms. They're in this phenoplastic kind of group. And they're also much more diverse in terms of habitat as well, which is interesting. Whereas family M, so Machimosaurids or Stenosaurids, they're much more linear in terms of their evolution. They start off as long snouted, your typical teleosauroid. Then they move on to more intermediate forms where their jaws and their teeth and their heads are getting much bigger and they're evolving. And then we get into Machimosaurians like Machimosaurus and Lemisuchus, where we do have they're eating turtles and massive, huge, over 7 meter long forms. So this is another simplified phylogenetic tree that my good friend and colleague W. Foffa put together with the paper that we're working on now, just to kind of show you again when exactly these specific taxa were living. So all the way from the lower Jurassic up into the Hauterivian that's been suggested for Machimosaurus rex. So quite a long period of dominance during this time in its history. So to go back into the environment a little bit, freshwater taxa, only the East Asian ones. I would love to see if we could find some more teleosauroids from China and from Thailand and potentially Japan as well. That would be great to see if they're also freshwater or if there's a little bit more variety there. We've got some that we've hypothesized to be slightly more semi-terrestrial because of the big, massive osteoderms, interlocking osteoderms. The majority of them, however, were coastal, which, okay, that's fine. They were absolutely dominated the coast throughout the entirety of the Jurassic. Then we've got one specimen, one species, Machimosaurus hugi, I believe, which is hypothesized to be slightly more open ocean. And then we've got more pelagic forms like Thalattosuchia, Saricodon, which have these characteristic orbits, smaller osteoderms, nice thin osteoderms, small forelimbs, which led us to hypothesize that maybe they're doing a little bit more benthic pelagic, more metrorhynchid-like environment. So just to give you a sense of where taxa have been found, you can see primarily it is dominated by European and UK localities. And here's this bias of collecting in these areas. However, we do have quite a few actually now that are coming out of East Asia, particularly in Thailand. There's a nice array of specimens from there. There's specimens that come out from Africa, Ethiopia, Madagascar, There's some teeth, I believe, from Morocco, and there's also, of course, Machimosaurus rex from Tunisia. And there's been this big Colombian Teleosauroid, which was published a few years ago as well from the late Jurassic, I believe. And then bits and pieces from North America that are currently Thalattosuchian indet or Teleosauroidea indet. And it's hard to tell if they are Teleosauroid or Metriorhynchoid just because they're so fragmentary. But this is evidence that at least the Thalattosuchians, they did get up into the States. They did get up into Mexico. So you can see that it's quite a wide range, a geographically widespread group. They're not just confined to one specific area, which is, I think it's quite neat that they were able to do that. And they were able to do it really, really quickly. So one thing that is kind of left over from my Edinburgh work is I'm looking with Davide and other colleagues at their dental and mandibular ecomorphology. So basically, we're doing a quantitative assessment, which is following Davide's work on marine reptiles. His paper was published in 2018. Please check that out. It's an amazing paper. So we looked at 17 dental characteristics and 16 mandibular or lower jaw characteristics for a multitude of species all across Teleosauroidea. So that was what we really wanted to see if we could do, if we could get a nice sample size throughout the entirety of the group and throughout the entirety of their evolution, of their evolutionary history, pardon me. And we were able to do that, which was quite nice. So we performed some principal component analyses, and we also mapped some significant ecological characters onto their phylogeny. Mandibular symphysis length, muscle size attachment, and two other characters for opening and closing of the jaws that were able to give us some information about maybe what they were eating. So basically what you just want to take away from these two pictures, the left is the teeth, the right is the lower jaw. So we'll focus on the teeth first. So Machimosaurines, Lemisuchus, Machimosaurus, they're in red. They're slightly more separated than the rest of the Teleosauroids, which all kind of meld together. They all cluster together. So this tells us tooth-wise, Machimosaurini are distinct. We knew that already because their teeth are conical, they're anastomos. They're quite different than any other Teleosauroid tooth. So they were clearly eating something different, but the rest of them, regardless of the habitat, regardless of the other osteological characters, their teeth don't differ a massive amount, which is interesting in itself. However, for the jaws, we see a little bit more distinct separation. So Teleosaurids, so the benthic ones, the East Asian taxa, they're in green. The more basal Machimosaurids, so the intermediate forms, they are in gray, and the Machimosaurini, so Machimosaurus, Lemisuchus, they're in red. And we can see that there's a nice trend almost from a more longirostrine form into a more mesorostrine durophagous form. Now, what the Teleosaurids are doing is they have a longer symphysis, makes sense. They have smaller muscle attachments generally, so they have a little bit of a faster bite as compared to Machimosaurini and their relatives. And we can see this on our heat map. So mandibular symphysis length up here deals with loads and bite force. So the Teleosaurids, they're generally dealing with a smaller load, and they have a bit of a shallower bite as opposed to the other turtle crushing Machimosaurids, pardon me. So looking at muscle attachments up here in the top left, the Teleosaurids, again, they have a smaller or a shallower muscle attachment, generally, again, and the Machimosaurines, They have larger muscle attachments, makes sense. They have larger skulls. They need more muscle for biting harder prey. You got to put that muscle somewhere. And so for opening mechanical advantage, again, teleosaurids seem to have a little bit of a faster bite as opposed to Machimosaurines, which have a slower bite. However, it's important to note that head size and total body size influences what you eat. So just because you're quantitatively plotting as, oh, I have a shallower bite, that might not be the truth in reality. For example, gharials are usually thought to, primarily eat fish, and they do. However, you get ones with almost a meter length skulls, and they can easily take down deer. That's no problem for them, just because they're bigger. And this is one thing that we have to be careful with this analysis, is that just because you have a shallower bite or you have a faster bite, just because you might be dealing with smaller prey, that doesn't mean that you wouldn't be able to take down something bigger. If you've got a bigger head, then we're able to do that. So basically, as some of our results, so Machimosaurini dentition, they're separated from other teleosauroids, but cluster all together, suggesting despite different habitats, different osteology, they're eating similar things. So for the mandibular characteristics, in general, teleosaurids have higher bite efficiency, they have a faster bite, they have smaller muscles. And Machimosaurids in general have lower bite efficiency, slower bite, larger muscles, but they make up for this lower bite efficiency and the slower bite by being really, really big. And as I mentioned, overall body and head size play a crucial role in prey capture, and that can, just because we're seeing something that's said to quantitatively have a shallow bite doesn't mean it does. If it's got a meter-long skull, it's probably going after something bigger. I mean, that kind of makes sense. So now, on to a little bit more of what I'm doing in Stuttgart, which is quite different. And to understand that, you kind of have to understand the Posidonienschiefer. So that's the Posidonia shale formation. Well known for its beautiful ichthyosaurs, beautiful fish, crocodiles, all these marine reptiles, marine animals, invertebrates, all beautifully preserved. So it's great black bituminous mudstones and shales. It's lower Jurassic in age. It's a marine or coastal environment, and the preservation, as I said, is exceptional, probably because of a cocktail of different factors like the anoxia, so oxygen depletion, constant sea level changes, and also other various climate and environmental variations that affect it. And it reaches throughout southern Germany, all the way up into France. So one thing that I'm doing actually 3 things for my postdoc. I've bitten off more than I can chew. But one thing that I'm doing is looking at body size distribution of teleosauroids within the Posidonienschiefer. And I can do this because not only is the record really, really good for marine crocodiles here, but the body size range from yay big to almost 5 meters in length, one species, Macrospondylis valensis. So we're going to be focusing specifically on Macrospondylis because it has such a good sample size, especially here in Stuttgart and the surrounding areas of Tübingen and Holzmaden. And we have, like I say, samples, the skulls range from 130 millimeters to over 1,000 millimeters. So, and everything in between. So what we're interested in is there a linear or a random pattern? Do they grow fast or do they grow slow? So here in red circles, these are all the layers within the lower Toarcian where we find teleosauroids in the Posidonienschiefer, from Lias epsilon 4 all the way up to 11/12. And we have representatives from all of these different layers. So what I'm doing is I'm gathering body size data set. And we're going to see if there is a pattern in, are we having the bigger ones, you know, specifically only in lies epsilon 1, 11, or do we see big ones all throughout these layers? So I've only been in Stuttgart for 3 months, but I've collected data from 66 specimens already, which, you know, it's a pretty good specimen collection here and in Tübingen, which is the bulk of my data so far, but I'm hoping to get to the Holzamaden, the Hauptmuseum pretty soon, as well as potentially some other German collections as well. As I said, we've got representatives from lies epsilon 4 or 5 all the way up to lies epsilon 12. We're going to focus on Macrospondylis because that's the best taxa that's represented. There's hundreds of specimens of this taxa, which is amazing. Right now, very preliminary results. It appears that larger individuals are more common in kind of the higher levels of this formation. So right up here is where we get a lot of the big specimens preserved. But again, this is very preliminary. I don't know if this is the case. We've got a lot more work to do with concerning the body size. However, this will be a nice flow into the second part of my project, which is going to be looking at paleohistology. So I'm going to be looking at ontology and histology of Teleosauroids, which has never been done before. So I have no idea what to expect. I have no idea if they grew fast, if they grew slow, if it's similar to modern crocodiles, if it's not similar. This is basically what we're going to be doing, again, with Macrospondylis, because there's so many specimens of this guy, it's ridiculous. So we're going to be doing thin section work, and we're potentially going to be CT scanning some femurs and some humeri as well, hopefully. So that's a little bit of a future problem, or a future fun problem, I guess, for me to do. And one other thing that we're doing, which I did not expect, but I think will be a really interesting side project, is looking at the taphonomy of these guys. So again, we're focusing on Macrospondylis in the Posidonienschiefer, and we were noticing a bit of a trend that a lot of these big specimens, they either have broken or dislocated jaws, as you can see right here in this poor fellow, and they also have either kind of a neck, like kind of a neck kink or kind of a neck break, like this one right here down at the bottom, or they've got their atlas axis complex kind of pushed up into the back of the skull, as you can see right here. And here we've got another neck break. So we were like, why? What's going on here? How did that happen? Were they falling weird? Is the sediment different? What is going on? So what we're going to be doing is we're going to be doing photogrammetry and associated heat maps to try and see if we can figure out which part of the specimen is higher than the other or lower than the other. We're going to be looking at the specific kind of the characteristic neck break, and we've already got some hypotheses of maybe what is causing this, but I won't talk about that yet, again, because this is maybe 2 weeks. We've just been talking about this for a couple of weeks. So this is very new work that I didn't expect to be doing, but I'm really quite interested in doing it because we have some folks in Stuttgart that are really good with taphonomy and doing photogrammetry and these heat maps. So hopefully we can figure out a little bit how these things might have been dying and compare them, the big ones, to the small ones. Are they doing the same thing? Are we seeing the same characteristic breakage and patterns in the jaw and the neck? So thank you very much for listening. I know I probably rambled a little bit and it probably went quite fast. But as I said, I just started the postdoc, so there's going to be a lot more Macrospondylis work coming out of Stuttgart in the next couple of years. We've already got some redescriptions on the go as well. If anybody's interested in doing a redescription or a master's project on Teleosauroids, again, please let me know. That'd be great to have some extra help with these guys. So yeah, that's it. And thank you very much for coming to my talk, and I'll be happy to take any questions now.
Thank you so much, Michela. I really, really enjoyed the talk. So it's nice to see some familiar crocs in a PERCS talk. So just a reminder that people can send their questions to the PERCS questions host, that today is Chrissy. So if you have any question about the talk, please send it to via chat. We do have some questions already that I'm gonna drop in the chat as well, so you can read them, Michela. Just find where the chat is. Here it is. So the first one is, why do you think the Teleosauroid record is more concentrated in Europe? And does the same happen with metriorhynchoids?
That's a really good question. Yes, they do also happen with metriorhynchoids, and just collection bias. There is so much Jurassic marine material here, particularly in Germany and the UK and in France, that we can collect from and we can easily access. Now, in Madagascar, for example, we just can't get to those outcrops. It's really, really, really hard to get to this one particular outcrop that nobody's even quite sure where it is. The same within China. We haven't been excavating in these lower Jurassic outcrops. So it's definitely sampling bias. It's just they're easily accessible here, and that's one thing. Hopefully, in the future, that we can maybe, focus a little bit on, and trying to see if we can, look into the Chinese Jurassic outcrops, or maybe get to Madagascar and try and find something, or Morocco, because we know they're there, and in India as well. We know they're there. We have at least one specimen from there. So yeah, it's hard to access those particular outcrops.
You made me think, so I have a follow-up question for myself. Do you think that this bias is caused by vegetation and this kind of stuff, or I mean, do you think that there are similar numbers of formations and rocks, Jurassic rocks, available in other places that we could sample more Thalattosuchians or other marine?
Yeah. So in China, I definitely think that it's feasible to do that. For Madagascar, I know for sure, because I've talked with a couple of people there, that this one particular area, there's tons of vegetation. It's almost impossible for a car to get up there. And you're not going to be walking up the side of this massive hill. Like you just can't do that. So there's definitely in those kind of areas, you just can't get there, right?
Yeah, that makes sense. Cool, thanks.
Unfortunately.
Yeah. So another question. So great talk. How come the majority of Teleosauroids went extinct around the end of the Jurassic? So
yeah, so that's actually one thing, and that's a really good question, because we don't actually know. So one hypothesis that has kind of been put into contention is that they just couldn't compete with because the mosasaurs were quite prominent in the Cretaceous, and maybe they just couldn't compete with that. Maybe there was some kind of environmental change that they couldn't cope with. But to be honest, we have no idea. And it's really hard to understand that, where we do have a Cretaceous Teleosauroid, from Tunisia. But again, we only have that one specimen, and we can't find anything from, the late Jurassic all the way up into the Hauterivian. There's just nothing there. We don't have the material. So I don't know. I will suck it up and say I just don't know.
Yeah, me neither. So another question is, do you have a possible explanation for the larger macrospondylus specimens being more commonly found in the top or more recent formations that you explained?
Yeah, that's another good question, and hopefully I can answer that within a few months where I actually have a little bit more time to do my analyses with my data. But again, I think maybe those particular strata are much more well sampled as opposed to Lias epsilon 6. Like we have some stuff from Lias epsilon 6, but compared to, you know, layers 10 to 11 to 12, we just, there's not as much. So again, I think there might be a sampling bias in that way. But I will know for sure more in the next few months.
Sense. Nice. So this one is cool. Not really related to Thalattosuchians though.
Oh no.
So the question is, are there any crocodiles which are herbivores?
Now, no.
Now, no, yeah.
Previously, yes. Example, Cymosuchus. Just Google Cymosuchus and you will fall in love with it.
Exactly.
It's really cute. Not only because it's a plant eater, but it has a squashed face. It's great. I love it.
Yeah. We do have a comment from Gilles Cunny in the chat. He's saying that if I remember correctly, it seems to me that a Teleosauroid has recently been found in Thailand.
Yes,
I think so.
and
yeah.
he's absolutely right. Martin et al. In 2019, they published a paper on Indocymosuchus potamocyanensis, which is from Thailand, and there was multiple specimens. Now we think there's another species in there as well, so 2 Indocymosuchus species. But yeah, there's starting to come a lot of stuff out of Thailand, and I think one reason we get a lot of Teleosaurid material is they're preserved in this kind of this cave area. So a lot of the bones are found in there, which I don't know if they've been protected or something, and they're doing a lot of digging within this particular area of Thailand. So I have a feeling more will be coming out.
Hopefully. Nice.
Fingers crossed.
So I guess that's all. I give you a few seconds if anyone wants to drop another question, but I think that was all for now. Yeah, I think so. So I think I'll take the screen share again. Yes. Right. So yeah, cool. So thank you very much, Michela. It was a very fantastic talk. I really enjoyed. Thank you very much.
Thank you for having me.
No worries. So I would like to remind people again that we have a weekly feedback form that someone is going to drop in the chat in a second. And please fill the form if you can. It's important for us. And if you can also, please join us for next week's seminar. Sandy Hatterington is going to be talking about the earliest preserved terrestrial ecosystems. And so now we're going to transition into tea time in a few minutes. And it's a great opportunity for you to ask other questions to Michela, and also the question, talk about subjects like the question of the week. If Michela has a favorite croc, living or extinct, and why she doesn't like terrestrial crocs. So yeah, we have a short 2-minute break. I'm going to start the timer, and you have a chance to stretch your legs, grab something to drink, and hopefully we're going to see you in a few minutes. See you.